Alright, here are our solutions to perfect problem 3 from Math 243. We're given some information about the distribution of IQ for Americans and height for adult males. And basically what it says is they're both approximately normal, and then it gives some information from which we can figure out the mean and the standard deviation. So what we'll use this throughout this problem, is this empirical rule. And basically what it's saying here is that 68% of the data lies within one standard deviation of the mean here, and 95% of the data lies within 2 standard deviations, shown in blue here, and 99.7% of the data lies within 3 standard deviations of the mean, in purple. And from this, and using symmetry, we can figure out some more stuff. If 68% is in the middle, then the remaining 32% is on the outside, so half of that, 16%, is over here and 16 is over here. And that same idea gives us the rest of these numbers. So using that, see, maybe we'll need a little chart here. We want to figure out the mean and the standard deviation for both height and IQ. See, I think the problem gives us some of that. It says the average American IQ is 100. Okay, nice. The mean here is 100. 95% of the people have an IQ between 70 and 130. So by the empirical rule, we know 95% is within 2 standard deviations of the mean. And so from 100 to, say, 130 is 2 standard deviations. So if 30 is 2 standard deviations, then 15 is 1 standard deviation. And we can figure out same stuff for height. Let's see, it tells us that, what does it tell us? Only 0.15% of adult males are taller than 79 inches, and 0.15% are shorter than 61 inches. You'll note we got 0.15 here in the empirical rule. It has to do with 3 standard deviations. So I think the easiest way is to first find the mean. Using symmetry, we can say, all right, the mean has to be halfway between 79 and 61. So 79 plus 61 divided by 2 is 70, and that'll give us the mean height up here in inches. And then standard deviation, well, let's see, you have to go up 3 standard deviations to make it so only 0.15% of the data is above that point. So if 0.15% are above 79, we know that 79 is 3 standard deviations above 70. So 9 is 3 standard deviations above the mean, so we get standard deviation 3. And from this information, we can answer the rest of these questions. Let's see here. We want to talk about the proportion of adult males taller than 6'3". So maybe I'll start drawing some pictures here. Let's do this one for height. I'll try my best to draw a decent bell curve. Harder to do than it looks. Doesn't really look like the one I did up there when I had more time. Then I can do one, hopefully it's the same. Not too bad for IQ. And so we know that the mean height is 70 and the standard deviation is 3. So 3 standard deviations should take us pretty close to the edge of the tail there. Same idea here. So this would be 73, 76, and 79 approximately, and 67, 64, and 61. And same idea for IQ. We want to go over 3 standard deviations and get pretty close to the edge of the tail. And same idea over here. We know that the mean is 100 and a standard deviation is 15. So jumping up 1 standard deviation at a time. Get something like that. Alright, and I think from that information we could figure out a lot of stuff. See, the question's asking about the proportion of adult males taller than 6'3", how tall I am. So let's first translate that. 6'3", there's 12 inches in a foot, and 6 times 12 is 72. So this is 75 inches, which will be helpful to use. So we want to compare that. Let's see, 75 inches. It's like right in here. I don't need to put my units in there. So 75 is here, the area above 75. It's talking about all that. and we want to compare that to an IQ below 86. Okay, so 86 is right around in here, and the area below 86 would be all of this. You can either look at the picture and say, all right, this looks like less than this, or a more precise way to do it would say the area above 75 inches is, let's see here, it's more than 1 standard deviation above the mean. So that means this area right here has got to be less than 16%, because 16% is the area above 73, and 75 is above 73. So the area above 75 inches is going to be less than 16% using the empirical rule. But over here, 16% is the area below 85 inches. The area below 86 is bigger than the area below 85. And the area below 85 is 16%. So this is bigger than this. So what's the question actually asking? Which is greater? So proportion of adult males, sorry. So the proportion of adult males with IQ, shoot, I'm getting this all backwards. So this one is bigger. So the proportion of Americans with an IQ below 86 is bigger. All right, good news, or maybe bad news, is that I get to do that again, so maybe I can do it a little bit cleaner this second time through. Now we're talking about the probability that an adult male is taller than Spud Webb. So Spud Webb is 5 foot 7 inches, which is the same as 67 inches. There's 5 feet is 60 inches plus 7 more. So in my picture, that's exactly this right here. So here's my 67 for Spud Webb, and we're talking about all the area to the right of this. And we want to compare that to the IQ of Abraham Lincoln, which was 128. So 128 would be somewhere over here. And then we're talking about the area that way. So kind of using the same logic, let's see, we could figure out exactly what this is. So the probability that height is above 67. Well, let's see. That's everything except for the probability that the height is below 67. And 67 is exactly 1 standard deviation below the mean. So that's everything but 16%. In other words, that's 84%. But if you look over here, the amount of people with an IQ less than Abraham Lincoln, well, let's see, 84% would be the amount below 115 using that same logic. And 128 is above 115, so this area is bigger. So what that's saying is this is less than the probability that IQ is less than 128. So I guess that answers the question. So probability of IQ less than Abe is greater. All right, finally, the last one says that Leonardo da Vinci has an IQ of 220. Okay, pretty impressive. Maybe I can squeeze that on the bottom here. IQ of 220. Well, let's see, the median IQ is 100. That's 120 above the mean. and a standard deviation is 15. So 15 goes in there 8 times. So that's 8 standard deviations above the mean, which is pretty damn impressive. To try to put that into context, if the standard deviation for height is 3 inches, we'd need to go 8 of these above 70. So a height as impressive. Is the average height 70 plus 8 standard deviations, which is 3. 8 times 3 is 24. 24 plus 70 is 94 inches, which is pretty damn tall. Let's see. 8 times 12 is 96. So this is almost 8 feet tall. This is 7 foot 10 inches. Maybe exclamation point. So the point that we're getting at here is Leonardo da Vinci had a pretty damn high IQ, if that's true. I mean, this was estimated from some website, but I guess that's the end of this perfect problem. If I explain this, yeah, good enough. So yeah, that's the end.